On page 3 of your notes, we talk about fractional exponents. And when we do that, we're looking at a base of a, which is a real number greater than 0, n being a positive integer. Then we can talk about a to the fractional exponent 1 over n equals the nth root of a. Similarly, a to the m over n is the nth root of a to the m power, and we can pull the power outside of the radical. When we multiply radicals together, they have to have the same roots, and if they do, we can multiply the radicands together under that root. So for this example, simplify 64 to the 2/3 power. One thing that you can do is rewrite it as a radical. The number on the bottom is the root, and the number on top is the power. Now I have a choice. I can put the power next to the 64, or I can put it on the outside. Now, either way, I'm going to get the same answer, but it's harder for me to think about what is 64 times 64 and then take the cube root of that number. It's a little easier to think of what's the cube root of 64, or what number times itself 3 times gives me 64. That would be the number 4, and then square that number, which is just 16. So let's try it with this next example, 25 to the 3/2 power. So the root is the number on the bottom, and the power is the number on top. You might also see it written this way on, for example, my math lab. If it's a square root, you may not see that root written in. It's assumed to be a square root if you don't see it. And then the power of 3. So the square root of 25 is just the number 5 to the 3rd power. So 5 times 5 times 5 will get us 125. And you can check this with your calculator. You can take 25 and raise it to the 3/2 power. You should also see that you get 125. Something you can't use your calculator on are the ones where the variable is under the radical. But the idea is the same. I'm just going to work backwards now. Now that I have the radical here, I want to rewrite it as a fractional exponent. So my base is x, the power goes on top, the root goes to the bottom. So 12 divided by 3 is just the number 4. That's x to the 4th. Okay, keeping that in mind with this problem and what we set up here, if I don't see the root, I assume it to be a square root. So there's a little 2 written in here. So this is x to the 8, that's my power. Root is on the outside, that's the number on the bottom. And 8 divided by 2 again, 4. We can also use laws of exponents like we did on the previous page to simplify. When I multiply like bases, I add the exponents. I don't multiply the 3 times the 3 together. The bases just brought along, and then add the powers. So I'm going to have to add 2/5 plus 1/10. Now, this is something that you could do with your calculator if you had to, or probably a little easier is just to get a common denominator of tenths. So I'd multiply top and bottom here by 2. So 4/10, which is the same as 2/5, plus 1/10. And then add the numerators together. That gives me 5/10, which reduces to 1/2. The direction says to write each answer with only positive exponents, so I'm going to leave it as an exponent of positive 1/2. When you raise a power to a power, that's when you multiply the powers together. So I have x to the 4 times 3 and 5 times 2. And then reduce your fraction down. So this is x to the 2 goes into 12. 6 times 2 goes into 10, 5 times. Or x to the 6/5. You could have also done a little cross canceling here and got that answer directly. I'm going to use our power rule again here, raising everything inside to the -1/2 power. So I have a to the, multiply straight across, -1 times 2, 5 times 2, and then b, negative times negative is positive, 1 times 1, 5 times 2. Reduce and get rid of negative exponents, so I've got a to the -1/5, b to the +1/10. And again, remember these are both in a numerator, so when I want to get rid of a negative exponent, I cross the line with it. The b to the 1/10 stays on top because its exponent was positive, but b to the -1/5, or I'm sorry, a to the -1/5 becomes a to the +1/5 in the denominator. And for the last one, again, we want to write it with positive exponents only, so I'm going to do a little rewrite here. This is the same as CD. The power is 3. The root is 6. Reduce that down. So that's CD raised to the 1/2 power. And then raise each to the 1/2 power. So C to the 1/2, D to the 1/2. So I rewrote the radical as a fractional exponent, power on top, root on the bottom, reduced, and then used the power rule. And my last two on page 4, same idea. This is a square root now, so let's think of it as to the 1/2 power. I have x to the 12, y to the 4, z to the 8, raised to the 1/2 power. And then when you raise a power to a power, we multiply. So I'm going to take half of 12, half of 4, and half of 8. Do the same with f. All right, so again, our root is 2, our power is 12. So this is x cubed y squared to the 12/2 power. Or 12/2 is actually 6. And then raise everything to the 6th power. So that becomes x to the 18. Multiply the powers together, y to the 12. All of these have positive exponents, so there's no need to cross the line and change the sign with them.